Well, you have the acceleration. You have the mass.
Yeah, you can, but don't drop it. It has like a yeah.
You have your acceleration, you have your mass.
Oh yeah.
Since you have the
Yeah, I
acceleration.
think we have to do something with kinetic energy if we are given the initial velocity and the square I, right? The final, no, the original. But the minus no, it has much. Yeah, so that is correct.
So hey, maybe it's easier if what's that?
Just use the kinetic.
Yeah, it's plus.
It's kinetic. We have to use it's the one that. Yeah. This we have. Oh wait. Yeah, we have our initial and we're
Yes, yes, you're right. This is 0. So that makes 0. This is square. And then 7, right?
You guys want to divide up the
Is there if I just join that?
yeah, it's kind of spread out really hard.
Okay.
Make a new one.
Yes.
No, I don't know.
Alrighty.
So we do MG, but that's
Okay, I'm gonna get started.
okay, so that's
yeah.
and then it's force. Kinetic friction is the only force this, right? So now this goes in there? Or no, this is
And the force is the friction
we
force.
need the force force. So is that MG? That doesn't have on it though. Remember it's like
Do what's my
Okay, I know how to do this. 49.
probably getting better.
What we did, okay, so
Right now.
I mean,
Okay.
yeah.
what is it?
Yeah, right now I just work on.
Oh, that, yeah, what, that's what we're
Okay, I got it. Who else got it?
Almost. One. Is it stopped at the end?
Yeah.
Okay, that's fine.
Oh, that would have been nice to do.
So,
Oh my gosh.
it's this, it just goes negative.
work.
And then this
But we don't see potential right now, there's no gravity.
Brittany, do you have
I just got in here, so no.
what's that?
I just got in here.
I can get it.
Hey.
You can come over here.
Okay, one.
Yeah.
what's N?
That looks like a reason.
Why don't you come over here and work with that?
Alright.
I don't care, I'm not if I don't know.
Yeah, but it's,
Okay, what do you get?
2.5.
I didn't do it yet. Wait.
All right, that's what I got too. 2.55. So let's go through that really quick. And who else? Did anyone else get it?
And what? We got
2.55.
we didn't get that. Times.
Anyone else get that? That, by the way, is a very flat surface.
Oh.
That's a very high coefficient of friction, but I might, effectively, I wouldn't say it's unreasonable. It's really unreasonable.
Sorry.
Let's go ahead and do this really quickly. While it's in this object, while it's in this region, it's negative. If I were to draw a free body diagram, the friction force would be pointing this way. There's a normal force and the gravity force. Do any of these forces do any work? I mean, does the normal force do work as it's moving this way?
No.
No, because the angle's 90 degrees between the distance moved and the force. How about mg? Same thing, right?
Mm-hmm. Yeah.
But this friction force will end up doing work. So the work done by friction is its magnitude of the friction force times the distance traveled, which would be 2 meters, times cosine of the angle in between the distance and the force. So what's that angle?
180.
180 because the distance is that way, and the friction force points that way. So this is negative friction d because cosine of 180 is negative 1.
Yeah, negative.
And then this friction force is mu k n. Pretty clear, hopefully by now, if you look at this, that the n has to balance mg. So I could write this as minus mu k mg d. Okay? Now, that's the only force that does work on it, so that's also the total work. So I have change in kinetic energy is equal to 1/2 mv final squared, that's 0, minus the initial, which is 1/2 m times 10 meters per second squared. That would be the change in kinetic energy. That has to equal the work. That'd be minus mu k mv d. So I can divide both sides by m. That's 0. I don't have to keep around, just keep that minus sign. Get rid of that minus sign. Divide through by gd. And so I get that mu k is 1/2 m, or 1/2 times 10 meters per second squared over gd.
Wait, what happened to cosine 180?
That's negative 1. Cosine of 180 is negative 1.
Okay.
Yeah. And if I plug in numbers here, I get 2.55. Make sense?
Mm-hmm.
All right, we'll do another one. This time I'll give you a 2-minute head start. When you're done, raise your hands and then just show your board, okay?
Yeah.
Thank
The
you.
answer box, that's all. Okay, a car initially moving with a speed of 10 meters per second decides to goes off goes down, this is, okay, it doesn't fall off the hill. We'll make it a little bit less steep of a hill. Goes down a hill that has a height of 50 meters. So that at the end of it all, it's going down here, it's down here. And I want to figure out what that speed is. V final equals question mark. So find the speed of this car that started out at 10 meters per second and went down a 50-meter hill.
Is this right?
Yeah. I'll give you guys a 2-minute head start and then I'll do it.
Yeah, no, that's right. No.
Yeah.
Final velocity zero.
No,
Oh, we're
final
flying.
velocity is gonna be much higher.
Just rather, also you're gonna use potential energy.
So it's in there.
Okay.
We have all that,
Yeah.
and then we'll just solve for b squared.
Just like kinetic.
So I would times divide by 2, and then divide by n.
Initial square.
We're solving.
Potential energy.
So we're gone. So we're solving.
Potential
Okay.
energy.
So just all of this.
Initial is non-zero. Oh, it's mg.
You put 0.5 or that
Energy
time.
is 0. So this is 0. And then what about kinetic energy? Oh, that's what we're looking for. That one.
Square root.
And here, what's it?
Yeah.
Oh, yeah. That's it. So,
Wow.
Oh, you already got it?
Yeah.
All right, let me go. I was just about to get started.
plus
So you guys, looks like you guys won up there if you got it right.
you got it right.
Oh, we're racing.
Of course you're
We're
ready.
racing.
Go as fast as we can. 32. What did you guys get, by the way?
Plug them.
24.2.
Uh-oh.
Uh-oh.
All right, let me.
We got first.
What you got? Yeah.
Okay.
That means we got
Yeah, so
So
we'll
the
try
first one's right.
We were
Yeah. You,
What?
I was done in like 15 seconds. You realize This is nice. What's it
I
got?
don't work at all this week.
And then take your square.
And then I got my Friday and my
Nice. Because like if you're nearsighted, like you can't see around you, so you have to
Good
focus
job.
on.
Okay, I got it now.
We got it too. We beat you.
Okay, so let's go hear some. Let's go hear some numbers. What do you guys get up there?
24.3.
Meters per second, right? What do
Yeah.
you guys get?
32.8.
Yeah, same with us.
So 8.6.
Yeah, 8.
What do you guys get? All right. Do you guys get it yet?
18.3.
They got the same as us.
Okay. Who did? Who didn't finish yet? Have you guys finished? Okay. Let's go ahead and see what it is. So this one is all the work's done by gravity, so you can introduce potential energy here. Okay. The only other force on it, if it's rolling nicely, is the normal force, and that doesn't do any work. So what I can do is I can say that the kinetic energy initially plus the initial potential energy is equal to the final kinetic energy plus the final potential energy. Okay? The initial kinetic energy is 1/2 mv initial squared. The initial potential energy, I'm going to call this h equals 0 here, and I'm going to call this just h, which is, I'll plug in 50 meters at the end, is mgh. That'd be 1/2 mv final squared, and then it's at 0 height, so 0 potential energy at the end. I'm going to divide through by m, and then I'm going to multiply through by 2. That gives me v final squared on this side. I'm going to take square root of both sides. I get that square root of v initial squared plus 2v8 is equal to v final. So I plug in numbers, 100, or 10 meters per second, squared plus 2 times 9.8 times 50, square root the whole thing. And I got 32.9 meters per second.
We forgot to,
What's that?
We forgot to take the 2 all the way through. That's
Oh, yep, that'll do it. All right. Ready for the next one?
Okay. Here we go. Yeah.
After this, I think we'll switch, a member from every, or 2 members from every group got to switch with some other group, okay?
So we got one.
All right, here's one. Cannonball gets launched off a cliff with a speed of 100 meters per second. The cliff is a big cliff, it's 500 meters. Okay, this cannonball launches down here, eventually hits the ground. Right before it hits the ground, it has a final speed. What is that? So, nope, I didn't tell you what angle it launches at.
Right before it hits the ground, it hasn't set. Let's do it.
Okay. You did the.
Dr. Graham.
You got it already?
We got it.
Oh,
Well,
like 9, 8.
I guess it's pretty much the same thing as last
6
time.
zeros. Oh, I didn't square it.
Okay, so you guys won.
Hopefully. Do we get a prize?
What'd you get?
40.7. Yeah.
I think I typed it in my calendar.
Are we gonna have to do any problems where
honestly,
we
it
can
takes the
buy
most time to just write it out.
Yes.
the,
Okay, there we go. Did you guys
What's
do
that?
are we gonna do anything where we combine like the P and the K and also have the friction force?
Squares.
Maybe.
Because does
I don't know why I didn't like that.
this all equal work?
All right, well, I'll tell you what we'll do. You can do something like that.
So doesn't all that just equal work?
You get, okay, who got that one? All right, what do you guys get?
140.7.
All right, that's good, meters per second.
Well, yeah.
All right, everyone get that, 140.7 meters per second? All right, let's go through it. We'll go through it really quick. So it's pretty much, this is actually the same, exact same equations as what we had on the previous one, right? So if I call this the initial, I can use the only work being done is the work done by gravity, because that's the only force on it. And so I get that, I'm going to use my initial kinetic energy plus my initial potential energy is equal to the final kinetic energy plus my final potential energy, okay? And this I'm going to say is 1/2 m the initial squared plus mg times the initial height is equal to 1/2 m the final squared. And I'm going to say that that final height's 0. Set h equals 0 down here. Okay? I can divide through by the m. I can multiply through by the 2. Same thing that we have here, had before, and we get that the initial squared plus 2gh is equal to the final squared. Take square root of both sides. That's your formula. Now plug in numbers. Square root 100 squared plus 2 times 9.8 times 500. And then that'd be in meters per second. Okay, and when you do that, 140. 0.7. 140.7.
Yeah.
Okay? All right. Okay, 2 people from every group switch with another group. Switch with other groups. Well, you have to switch. Yeah. So Alan, you can go over there. Go over there.
Yeah, there you go. Oh, he went over there. I'm in the middle.
Basically, we need completely new groups.
Say just don't.
What's your closest? Mine? Yeah, I'm right. I'm just the middle one. What? After yeah.
How about your thing in your doctor?
Yeah.
Yeah.
Bryce, what's your major?
We all did.
Did you take your pencil with you and slowly gonna use your pencil?
Yeah. There you go.
Actually, 5,000. Okay, so here's the problem. We have somebody jumping out of an airplane, hopefully with a parachute. And they're 5,000 meters above the ground to start out with. At the end, they are going with a speed of 12 meters per second.
That's it.
What's that?
That's it.
So the question is, how much work was done by gravity? By gravity, what was total work?
How much does the skydiver weigh? Do we need to know that?
And ignore the speed of this plane, forward.
Is that the final then the 12?
Okay.
Maybe it'd be better if it was base jumping or
This was
something.
actually one of the questions on the homework.
All right. What was total work done? And then the final question is, what other force did you do?
Yeah.
How much?
Is he massless or what?
Oh,
Let's begin with.
Matt.
Oh, we need it for the fourth.
Let's do 50 kilograms. Very good.
I was gonna say, we need it for the.
Yeah. Very, very good. Important.
Kinetic inertia is 0. So
Yeah.
Yeah, we'll say the plane.
Number 1, so
That's
it's
out.
just
Without going.
the mg times 5,000.
Square. What do we solve? We're solving for.
But we have
Oh.
so. Or, no we don't. We'll find it.
Okay, words equals, of course.
Work total is so. Yes, but it's. Oh, work gravity. Okay. So we're doing work. So it's gonna be every
Yeah,
right?
yeah.
And then F is just MG, right?
Yeah.
The first one to find all the circles.
In the distance, do it. I
got it.
And
Did?
then cosine theta is.
It's in the same direction.
So it's 0?
Yeah.
Alright. Did you guys get it? This is what I got. So how do we just... Wait.
Yeah, we're gonna have to
Group these two around.
Okay.
I did the wrong side of the equation.
This is what I got.
That might be why.
But we didn't use that velocity at all.
Well, we have to find good total force. So we're
Oh.
Okay, and then what's the work done, what other was How much work?
Yeah.
That would be.
And then the initial is 0.
Yeah, work total.
Cool. I didn't see that.
So this would be what?
That one.
Yes.
50 times.
Think about how their acceleration meters per second, and there's no error system. Just continue that for a reason. It's going to improve acceleration.
Okay. Now I did it right.
Yeah.
I don't know.
He's the only one who forced after the music.
I think this is right.
What's
That looks right.
What's the total?
Yeah.
It's
VI is 0.
squares, right?
Oh, what other force did work? Friction there.
Oh, MG right here.
He just wants total work, which is the energy, chain kinetic energy. KEI
Would be MG, right?
is 0. So it's not. It's just falling, right?
We got ours.
Okay, good. So who has theirs?
Answer.
Does everyone have an answer? All right. Well, everyone, okay, let's go through it then. So the first one, how much work was done by gravity? Well, the gravity force goes downwards, mg downwards, right? And the distance is also downwards. So the work done by gravity would be mg times the distance it fell, and then cosine of 0, which is 1, because they're in the same direction, the force and the distance. And when I plugged in numbers for that, I ended up with 2.45 million joules. 10 to the 6th joules. Okay?
Oh, okay, yeah.
The work total is the change in kinetic energy. So if it started out at rest, which I guess would be hard to do from an airplane, maybe it's a helicopter. The initial speed is 0, so initial kinetic energy is 0. The final would be what we have there. So I get 1/2 m v final squared minus 1/2 m times 0. That's the change in kinetic energy, so I'm just going to leave that off, the 0 off. If I plug in numbers, times 50 kilograms times 12 meters per second squared, I end up with 3,600 joules. Okay? So this work is clearly not the total work. There's got to be something else doing work on it. So that'd be the air drag, right? We could figure out the work done by air drag. That's, I guess, not technically part of the problem. I'm going to put the work, the drag. First of all, the total work is the drag work plus the gravity work would be the work total. And so I just plug in numbers here, or I can solve for this drag work. Work total minus work of gravity. And I would get a result of, didn't have to do this, 4,464 times 10 to the 6th joules. So, and it's minus.
You have a negative one.
It's negative because the drag force is pushing it upwards, and he's coming downwards. Make sense? Okay, let's see if we can do another one or two. All right, this one combines circular motion and the energy work. So we go down the hill. Let's say that this guy starts out at rest here. This one will be tough. Let's call this hill H. And let's say this hill is kind of a half circle shape, okay? And we can call the hill having a height of R. What is the maximum height that this car can be dropped from so that it stays on this hill? Max 8 such that the car stays on hill. I mean, doesn't jump on, doesn't make it, doesn't catch air. Okay. So you'll want H and you want to just find a relation between H and R, H and turbine. Okay. This one's a little tricky. It's all, this one's sticky.
So we just gotta find the formula, basically?
Yep.
Okay.
So we do change.
So it can't be
Because
because if it was,
it won't be.
yeah, so if it's like because we can do a whole
NGR.
so he doesn't know.
Basically, final height is just.
Because it's what we did yesterday when we.
Yeah.
So,
Divide by
Because that's what we did yesterday.
yeah, so basically we're just doing, velocity.
I know it's not, this is different than 2 hours, because it's an actual. We don't have
And final
Yeah.
velocity.
that's what I'm assuming.
Velocity of that point,
With MGH.
Yeah.
which is gonna be,
And then
Really? I'm just trying to get this out. No, like I told him, I said, why can't we just?
what are we looking for? We're finding, so divide by MG.
we need to figure out what velocity is
How final?
in relationship to R. At the end of that.
All right, I got it. You guys got it? What'd you get?
3.7. Know what this is. So what's the equation of velocity on?
That's a tough one, too.
Well, we had one kind of similar yesterday,
What's the
but,
equation for velocity on a circle?
yesterday's problem.
It's B squared over Y. Yeah.
B squared.
Yeah, that's good.
Acceleration B squared over Y. So we plug in that over some that's what this is. Okay.
That's acceleration.
Yeah, I don't
You know that
That's
centrifugal
not right.
acceleration is, mv squared over Y. One.
Well, that's sum of forces have to equal.
Yeah.
Sum of the forces.
I'll make my joke.
Oh, because this is force equals. So this. So we do. So you do this.
Yeah,
Because I know
this is what I got. Which was considered key. Yeah. But I have
But I don't think this is all
Unless we find we can input into that.
Yeah. All we're doing is, sorry. Zoned out.
Why is it too far?
Are you,
Oh, by the way, in case you were in lab and you didn't get the announcement on Blackboard, there's no error analysis for this week's lab. We decided there's just too much possible things
Sweet.
to do uncertainty propagation on. So we're just not going to do that this week, okay? Just focus on the physics.
So what do we put in that section then? Just, what do we put for the error propagation section?
Don't worry about it.
Just like delete it off of the report? Okay.
Okay, we'll just spread those points over the rest of it. Well, there's a calculation. It's calculation.
Okay. Okay.
Yes.
It starts out, it's like
It's 1 over 2.
that was a tough
And then I subbed in
So you put plus.
for that.
So I had,
His,
yeah, so you, like I got K, so like that formula, you got 0 to
Where did that go?
So then each of those energies plugged in. You have like d squared over r equals 1/2
Yeah.
d squared plus md squared over r.
half of the R over, I mean, half of the math.
So that's r squared.
Oh, and the G squared.
And then you can add that with the one that's you get that.
So H equals.
md squared.
Yeah.
Same as what we did.
All right, raise your hand if your group has an answer. Okay, what do you guys get?
2/3 are.
2/3 are, okay. What do you guys get?
3/2 are.
3 halves are.
Yeah, 3 over 2.
3 over 2 are, excuse me.
Okay, good.
2/3.
You guys got 3 halves are, 3 halves are. Who else had, did everyone have 3 halves are? You got it?
We got like 5
Okay.
It's just.
Let's go ahead and do this real quick then, in the last 4 minutes. So I'm gonna draw a little free body diagram for this car when it's up at the top of the hill. It has a normal force going upwards, potentially, and the gravity force going downwards. Now, the sum of these forces has to be equal to whatever it takes to be in circular motion. So that's m, v squared over r downwards. The condition for it to just barely remain on the hill is we set the normal force equal to 0. So we go, that means it's just barely touching. So sum of forces in the y direction would be normal force minus mg, and that would equal minus m squared over r, because this v squared over r is the acceleration in the negative y direction for circular motion. Does that make sense to everyone? That's the centripetal acceleration. When it's on this hill, it has to be accelerating like that if it's on the hill. Okay, and I'm going to set this to 0. So I get mg is mg squared over r, like that. Is the condition for, is what we get relating gravity force to centripetal acceleration on the hill. Okay, so now here when it's gone down, come up to this hill, let's see if we can figure out what the speed is at that point.
Why does it equal mv over r?
What's that?
Why does it equal mv squared over r?
So this is minus, this is may, right? If it's moving in a circle, which this is, right? A is v squared over r, pointing towards the center of the circle.
Oh.
So ay would be negative v squared over r.